After the definition, now we are going to discuss its a theorem. So that theorem is show that sum of two subspaces of a vector space is a subspace of vector space. So check करूया मेन क्वेश्चन काय काय दिलेला आहे की सम ऑफ टू सबस्पेसेस म्हणजेच आत्ता आपण वरती बघितलं दॅट इज W1 प्लस W2 हा काय प्रूव्ह करायचा आहे आपल्याला सबस्पेस प्रूव्ह करायचा आहे अंडर सेम वेक्टर स्पेस. इथे सुद्धा सेम वेक्टर स्पेस यायला हवा आहे म्हणजेच हे जे काही कंडिशन आहे या इलेमेंटला सबस्पेस आपल्याला प्रूव्ह करायला लागणार आहे. सो सबस्पेस प्रूव्ह करताय म्हणजेच काय काय असेल पहिली कंडिशन नॉन एम्प्टी, सेकंड कंडिशन क्लोजर प्रॉपर्टी विथ रिस्पेक्ट टू ॲडिशन आणि थर्ड प्रॉपर्टी क्लोजर प्रॉपर्टी विथ रिस्पेक्ट टू स्केलर मल्टिप्लिकेशन. सो विथ द हेल्प ऑफ दिस थ्री कंडिशन वी कॅन डायरेक्टली से दॅट एनी फंक्शन इज अ सबस्पेस. म्हणजेच आपल्याला या तिन्ही कंडिशन काय करायला लागतील प्रूव्ह करायला लागतील 1 by 1. सो मेन आपल्या या थेरमला प्रूव्ह करण्यासाठी वेक्टर स्पेस पहिला कन्सिडर करून घेऊया. सो लेट व्ही बी द वेक्टर स्पेस. सिमिलरली कन्सिडर टू सबस्पेसेस. सो लेट W1 and W2 be two subspaces of vector space V. Now with the help of this definition, that is by definition W1 plus W2 can also be written as small w1 plus small w2 such that this small w1 belongs to this from this capital W1 and this small w2 belongs to this capital W2. So this is your set. So now only we have to check this set is a subspace or not. We have a two given condition, that is W1 is a subspace of V. Similarly W2 is a subspace of V. So only we have to consider these two conditions, that is W1 and W2 both are subspaces of V. So that means हे दोन्ही सुद्धा जर सबस्पेस असेल तर पहिली कंडिशन कुठली आहे नॉन एम्प्टीची. हे नॉन एम्प्टीची कंडिशन दोन्ही सुद्धा सेट काय करतील सॅटिस्फाय करतील. दॅट मीन्स W1 इज ऑल्सो नॉन एम्प्टी सेट सबसेट ऑफ दिस वेक्टर स्पेस अँड W2 इज ऑल्सो नॉन एम्प्टी सबसेट ऑफ दिस वेक्टर स्पेस. देअरफॉर नॉन एम्प्टी असेल तर W1 मध्ये कमीत कमी एक इलेमेंट असेल. सिमिलरली W2 सुद्धा जर नॉन एम्प्टी असेल तर त्यामध्ये कमीत कमी एक इलेमेंट असेल. दॅट इलेमेंट इज आयडेंटिटी इलेमेंट. सो दॅट इम्प्लाइज if 0 belongs to W1, this is true because W1 is a subspace आणि सबस्पेसमध्ये पहिली कंडिशन काय असते नॉन एम्प्टी. नॉन एम्प्टी म्हणून कमीत कमी एक इलेमेंट यामध्ये प्रेझेंट केला आहे. सिमिलरली W2 सुद्धा काय आहे सबस्पेस. देअरफॉर 0 बिलॉंग्स टू W2. सो दॅट इम्प्लाइज 0 can also be written as 0 plus 0. Yes, and this first 0 belongs to W1 and this second 0 belongs to this from this W2. Now check, this is nothing but like this. So W1 plus W2 such that first element must belongs to capital W1 and second element must belong to capital W2. Similarly we have now this relation as like this, that is 0 plus 0 and first element belongs to W1 and second element belongs to W2. Therefore this element must belongs to this element, that is 0 plus 0 that is equal to 0 which belongs to in this set, that is W1 plus W2 which is a subset of vector space. That is W1 plus W2 मध्ये कमीत कमी एक इलेमेंट प्रेझेंट झाला, दॅट इज आयडेंटिटी इलेमेंट आणि तो सबसेट कुणाचा असेल वेक्टर स्पेसचा. हेच आपल्याला पहिली कंडिशन प्रूव्ह करायची होती. दॅट इज W1 प्लस W2 इज नॉन एम्प्टी subset of vector space V. So this is your condition number 1. Now to prove it's a second condition, so for that purpose just consider two elements from this set. Now only check is this closed with respect to addition or not. So for that purpose we can separate these two elements, like x belongs to this W1 plus W2 and this y belongs to this W1 plus W2. And with the help of this W1 plus W2 definition we are going to write these two elements like this, that is if x belongs to w1 plus w2, that is this can also be written as x is equal to small u1 plus small u2, such that this u1 belongs to this capital W1 and this u2 belongs to capital W2. This is possible with the help of given condition, that is given definition. Similarly, this y also belongs to w1 plus w2, therefore this set can also be written as like this, that is y equal to w1 plus w2, such that this w1 belongs to this capital W1 and w2 belongs to this capital W2. So this is your second condition. Now to check closure property with respect to addition, just add this element to this element, that is consider x plus y is equal to, x is equal to how much, this set, that is u1 plus u2, this is our first bracket, plus y can also be written as like this, that is w1 plus w2. Now add those elements, that is now we are going to change, that is u1 plus w1, this is our first bracket, and second is u2 plus w2. Now check one thing, that is u1 belongs to w1, w1 belongs to w1, therefore u1 plus w1 also belongs to capital W1, therefore this first term, that is u1 plus w1 belongs to capital W1. Middle term is addition, that is addition. Now check this second term where it belongs. So as u2 belongs to w2 and w2 belongs to capital W2, then its a corresponding addition also belongs to capital W2, therefore u2 plus w2 belongs to capital W2. So we have obtained x plus y, this term, this belongs to w1 plus w2. For all this x and y each belongs to w1 plus w2, that is for all x comma y belongs to w1 plus w2. So we have obtained this equation number 2, that is closure property with respect to addition is satisfied in this set. We have already obtained in equation number 1, that is this set is non-empty. Now we have obtained, that is a closure property with respect to addition is satisfied. Now to check its a last property, that is let one element from field, that is let alpha belongs to field, and let one element from our given set, that is x belongs to w1 plus w2. Therefore with the help of this set we can write this x as x is equal to small w1 plus small w2, such that this w1 must belongs to this w1, that is small w1 belongs to w1 and small w2 belongs to this capital W2. So this x belongs to this set, therefore x can also be written as like this. Now only check it's a scalar multiplication, that is alpha into x. So consider alpha into x is equal to alpha as it is. Now consider alpha into x is equal to, take alpha as it is. Now in place of x we can write this value, that is w1 plus w2 after multiplication. Alpha into w1, is it possible? Yes, because we have already given a condition, that is w1 is a subspace of v. So subspace already आहे, म्हणजेच ह्याच्यामध्ये तिन्ही कंडिशन काय असतील, सॅटिस्फाय असतील. पहिली कंडिशन नॉन एम्प्टी, सेकंड कंडिशन क्लोजर प्रॉपर्टी विथ रिस्पेक्ट टू ॲडिशन, आणि थर्ड प्रॉपर्टी कुठली असणार आहे, क्लोजर प्रॉपर्टी विथ रिस्पेक्ट टू स्केलर मल्टिप्लिकेशन. म्हणजे W1 मध्ये क्लोजर प्रॉपर्टी विथ रिस्पेक्ट टू स्केलर मल्टिप्लिकेशन पॉसिबल आहे. त्यामुळे जो आपण आता फाइंड केला अल्फा इंटू w1 हा मल्टिप्लिकेशन पॉसिबल आहे. देअरफॉर वी कॅन राईट अल्फा डॉट w1. सिमिलरली w2 सुद्धा स्वतः काय आहे, एक सबस्पेस आहे आणि सबस्पेसच्या डेफिनेशननुसार ह्यामध्ये सुद्धा थर्ड प्रॉपर्टी, दॅट प्रॉपर्टी इज क्लोजर प्रॉपर्टी विथ रिस्पेक्ट टू स्केलर मल्टिप्लिकेशन इज ऑल्सो पॉसिबल. देअरफॉर वी कॅन राईट दिस अल्फा इंटू w2 and with the help of w1 is a subspace, w2 is a subspace, therefore first element must belongs to capital W1 and second element must belongs to capital W2. So we have obtained now alpha dot x, this element belongs to this set, that is w1 plus w2, where this alpha belongs to field, that is alpha belongs to field, and this x belongs to from which set, w1 plus w2. So we have obtained this equation number 3, and equation 3 says that closure property with respect to scalar multiplication is satisfied in this set. So we have obtained equation number 1 as a non-empty set, equation number 2 as a closure property with respect to addition, and now we have obtained this equation number 3, that is closure property with respect to scalar multiplication. So with the help of theorem number 1 of a subspace, we can directly say with the equation 1, 2 and 3, that is W1 plus W2 is a subspace of V. That is, we have proved that sum of two subspaces of a vector space is again a subspace of vector space.